Hello, and welcome to Easy as Pie with Mr. Carpenter. I am Mr. Carpenter. If you're watching this, you're likely an Algebra 2 student who wants to make sure that they are properly kicking butt on their complex numbers exam. So let's take a few moments and talk about the review, make sure that we know our strategies going in for every single question. This should be a very straightforward exam for you, provided you put in the right work. A lot of execution, a lot of busybody work, but not a lot to remember, right? What we are remembering is how we define the number I, which we define as the square root of -1, right? That imaginary number. And from that, we derived I squared, which by definition must be -1, I cubed, which must be -I, and I to the fourth, which must be 1. And then if your exponent is larger than 4, you would then divide by 4. So if we're larger than 4, then we divide by 4. And if that decimal ends in 0.25, well, then we know it will simplify to I. If it's 0.5, that's -1. 0.75 would be -I. And then, of course, if it's divisible by 4, comes out to a nice number, then it will turn into 1, right? And these very much correspond with each other. And this comes into play right number 1. What is I to the power of 3001? Well, the exponent is larger than 4, so I'll take 3001 and divide it by 4. And I will grab my phone calculator off to the side because I don't know what 3001 divided by 4 is. It's 750.25, right? And that decimal ends in a 0.25. So therefore, it must be I. Highlighter, bam, it must be I. Moving on, number 2, which expression is equivalent to this square root? Remember this very, very important rule with square roots. It's kind of at the crux of what we do with square roots a lot. If I have the square root of two numbers being multiplied, I can break apart the square root of the factors. So the square root of A times B is the square root of A times the square root of B. Right? So if this looks too complicated, we can break it up, right? Square root of -16 times the square root of 8 to the 12th. And we'll look at them individually, right? Square root of -16. Well, the square root of 16 is 4. So the square root of -16 would be 4i, right? At any point, I can just get rid of the negative sign inside the square root and just pop an I out on the side. So the square root of -16 is 4i. And the square root of 8 to the 12th, right? If we're taking the square root of an even exponent, we can just divide the exponent by 2. So 12 divided by 2 is 6. So we got 4i to the 6th. And we are all good on that regard as well. Last one for the multiple choice, which expression is equivalent to root -99. So once again, we can ignore the square root. We can ignore the negative number. We can just get it out of the way. When we get rid of that negative inside, we'll just throw an I outside. So right now we have I root 99. And simplifying the square root is going to be the same thing that we did in Unit 1, right? We're going to look to break this up into two factors, right? So two different square roots of two numbers that multiply to 99. And ideally, one of them is going to be a perfect square. For example, maybe you noticed it or maybe you didn't, but I can rewrite the square root of 99 as the square root of 9 times the square root of 10. 11, sorry. Because 9 times 11 is 99. And the square root of 9 is 3. So we'll get 3i root 11, right? The square root of 9 is 3, so I replace the square root of 9 with a 3. And now I have 3i root 11. The root 11 I cannot simplify any further because it's a prime number. So this is where I'll end with at 3i root 11. And then lastly, question 4 is just 12 different simplifications of imaginary numbers. This includes the following things that I will make sure we remember. It includes fully simplifying all imaginary numbers. That means if I is raised to any power that's not 1, it is not fully simplified. So you must simplify those imaginary numbers. And this also means reducing fractions. Right? So if I have 6 over 10, those are both even numbers, so I can cut them both in half and reduce to 3 over 5. Right? Divide them both by 2. So both of those things will lose you points if you do not simplify. Right? Then the other thing we're falling back on is our exponent laws. Right? So we have I to the 5th times I to the 10th times I squared. Right? They are the same base, and they are being multiplied. So I keep the base and add the exponents. 5 plus 10 plus 2 is I to the 17th. And do not stop there, because as you can see, that exponent is bigger than 1, so it is not fully simplified, right? I have to do 17 divided by 4, which is 4.25, right? The decimal ends in a 0.25, so this simplifies to I. And I will put all final answers in red. The other thing that you can do, if you really would like to, is you can, and I'll put this in gold, you can simplify the i's first before you multiply them out, right? So you kind of get to avoid the product rule. For example, I know I to the 5th is I. I know I to the 10th, I believe that would be -1. And I squared would also be -1. Right? So -1 times -1 is 1. So we get I times 1, which is still I. It will get you the same answer. So it is just a matter of preference, but that is an option. You can simplify those before you do any multiplying, any dividing, or whatnot. Square root of -90, same thing that we looked at in number 3. First of all, we can just think of this as a square root of 90 and throw an I out in front. Right, get rid of the negative sign, throw an I on the side. Now, how can I rewrite the square root of 90 so that it's multiplying two numbers, and yet one of them is a perfect square? Right, my perfect square is 1, 4, 9, 16, 25, da da da. Well, if you see it, we can do 9 times 10, and that is the best one that we can do here. So we get I, and actually, I'll put final answers in red, so I'll keep this in black. So we got I root 90. And I can rewrite that as I root 9 root 10. And what's the square root of 9? Well, it's 3. So we get 3I root 10. Once again, the square root of 9 is 3, so I can just replace it. So we get 3I root 10. And because the only factors that I can make of 10 are not perfect squares, I am fully simplified here. And this will be my final answer, 3I root 10. Moving on, just some distribution, right? Term on the outside gets distributed by all the terms on the inside. -12 times 3 is -36, and I times I is I squared. And -12 I times -2 is positive 24I, right? Now I look to see if I have any i's raised to any exponents. And I do. I have an I squared. I squared is -1, so I will replace it with a -1. -36 times -1 is positive 36 plus 24I, and I am all done. Now let me erase a little bit so you can see that I to the power of 47, that exponent, is bigger than 4. So we divide by 4. 47 divided by 4 is 11.75. So the decimal ends in 0.75. So this is -I. Moving on. And I will erase that circle as well. They keep on covering up questions. You can do one of two things. One, you can do the power rule, right? So that 11 is raised to a power of 1, and the I is raised to a power of 6. And they are both raised to a power of 2, right? So it's one base being raised to a power, raised to another power. So we can do the power rule and multiply the exponents by distributing. So we'll get 11 squared, 11 to the power of 2 times 1, which is 2. And then I to the power of 6 times 2, which is 12. Now, if you'd like, you can just rewrite this as repeated multiplication, right? So we got 11I to the 6 times 11I to the 6, right? Squaring something means you multiply it by itself once. And then you get the exact same thing, right? Because we'll get the 11s will multiply and the I to 6s will multiply as well. Regardless, 11 squared is 121. And I to the 12th, 12 divided by 4 is 3, which is a divisible number, decimal 0. So 121 times 1, which is just 121, and we're done. 9 minus I times 9 minus 9I, lots of 9s, lots of I's. We're just going to be foiling, right? So we distribute the 9, and we distribute the negative I, right? Just double distribution. One step at a time. 9 times 9, that's 81. 9 times negative 9I is negative 81I. Negative I times 9 is negative 9I. And negative I times negative 9I is positive 9I squared. There is a lot of simple mental math that could go wrong there. So being very careful and methodical is in your best interest. And also not forgetting negative signs is also in your best interest. So there's an I squared. So I squared is negative 1. So I can replace that with a negative 1. And then we will get negative 81I minus 9I is negative 90I. And then 9 times negative 1 is negative 9, and 81 minus 9 is 72.